So their Docker containers are cool. And it turns out for building a complex software development environment, they're great. But one of the things is, how do you get your code onto and on and off of the container? And so there are two ways. One is to mount the code onto the container, and the other is to copy the code onto and back off of the container before you destroy it. So there's another talk I did on how to mount your source code from your local machine onto the container. You can go find that. There'll probably be a link on this video in the description. The other way is to copy code on and off. And there are really two main ways to do that are useful. And both of them work on your local machine, and one of them works reasonably well in the cloud. So the two ways to copy those on and off, really, you know what, let's just do this. So there are really two ways. One is you can copy to and from your local machine using Docker CP, right? And so the example here on the left, on my machine, I'm going to do a Docker CP -- documents my project to the remote directory, and that would be like whatever the path is, not the word remote. And then when I'm done, I need to copy it back. I need to copy from the remote back to my project to pick up the changes. So you'll note here that basically the Docker machine has its own disk drive that's isolated from the host, especially if it's in the cloud. And so they both don't appear on the host. I mean, they kind of do in local, but let's pretend they don't, because that would be dumb. So in this case, what we're going to do is we're going to basically have a repo on our local developer machine, and then we are going to Docker CP it in and out. Now, it's a little cumbersome unless you can get the whole path on the Docker CP, and you can do basically the whole directory, right? But if you get a whole big nesting thing, a little more complicated. The other way to do this is use source code repo. So on the right-hand side, you can see where we have a source code repo. We're going to pretend that that server on the top is actually a source code repo, because I didn't want to make the picture any more complicated. So whereas before on my machine, I pushed it and pulled it from the container's disk drive, in this case, I'm actually on the Docker container, and I'm going to pull it from the repo onto my local drive, and then I'm going to push it back. So both of these are a little different. One of them, we do the work from our machine into the container, and the other, we do the work on the container, pulling stuff into the container and pushing it back out to the repo. So I like the Git part. It especially works well if it doesn't have to be Git. It could be any repo. But if you're in an environment where you don't have any of that, then maybe the Docker CP thing. Sometimes you'll see people do Docker CP my zip file, and then they'll edit it, and then they'll unzip it, and then they'll zip it back up and pull it back. Gag. The other way, like I said, was the local mount. So what does this mean for IDEs? Well, there's actually two ways to do development, right? So the copy of the code only exists to be run on the container, whereas in the mounted version, we could actually do software development on the host, and the changes would appear on the container, and then we could run it. In this case, we need to do the software development on the Docker container. So there are two ways. One of them is you can do something like Visual Studio Code. So in the case of Visual Studio Code, we run Visual Studio Code on our machine, and then we tell Visual Studio Code to connect remote. It actually has a remote button, and you can tell it what Docker container to connect to. It will actually SSH into that container, or basically open a bash shell, and then it will install the Visual Studio Code remote server on that Docker node. And then basically, you got two copies of Visual Studio, a graphical one and a non-graphical. And everything you do on the graphical one on your machine appears on the server. And then everything that, and then the remote server just basically runs everything. And then when you, source code control also works, because the remote visual code server that's installed has access to source code control. So you can do all the git, put, pull, or other repo style things that you want to do. And that'll all happen on the Docker container, which is cool. I guess you could cheat too. You could do work on the Docker container, and then you could copy and paste out of the Visual Studio window back onto your box. So in this case, though, we run the IDE on our local machine, connected to a headless version of the IDE, but the software is actually still developed on the Docker container. The other route is you can run the IDE on the Docker container. So obviously Jupyter Notebooks are a really good example of that. Matter of fact, that's a lot of the time people do container development and machine and data science work, we can run our Jupyter Notebook server on the Docker container. So it can edit all the files there, and then you just got to figure out how to do the copy on and off. You can either log in and do git push pull. I don't know if Jupyter Notebooks have access to source code control system. They might. Or you could, well, really that would be the only option then, right? You'd have to log into that box somehow. Or you could do the Docker CP thing and you could push your Python or other files back and forth. So that was the big two, right? One is to run the IDE on your local machine and remotely connect to the container because the files are there, right? We didn't mount them. We copied them onto the box. And the other way is to use the IDE that is actually installed on the box. And that's it. So that is yet another way to do software development on a Docker container. Have a great